So if you add or subtract the same number each time, that number doesn't change. If you add or subtract the same number each time, you have an arithmetic sequence. And we're going to take a look at an arithmetic sequence. So we're supposed to figure out, are we adding or subtracting something every time? Because if so, it would be arithmetic. Are we multiplying or dividing by something every single time, and it's the same thing? Because if so, that would be geometric. Or is something else entirely happening? Like maybe we're adding a different number each time. That wouldn't be neither. So what happens on this one? So she was saying that, well, the decimal goes 4, 9, 4, 9, 4, 9, and so on. So we can figure out the next numbers. Negative, it would be something 0.9, and then something 0.4, right? Negative something 0.4, and then 0.9 and 0.4. That's what she's saying. Except for the numbers are decreasing. So we have 9, then 8 and 8, then 7 and 7. So this will be 6 and 6. And 5 and 5, and 4 and 4, and 3 and 3, 2 and 2, 1 and 1, 0, 0, positive 1, because these are negative numbers, right? What's happening between these two numbers? Say it again? Plus 0.5, is that true? Check that out. Try it. Yeah? What about to get from here to here? Is it the same? So without even knowing what we're adding, we could still figure out just by using a pattern. But if we want to know what type of sequence it is, we do have to figure out how we're getting from one to the next, using either add, subtract, multiply, or divide. So what's the answer to this one if we're determining the type of sequence? Arithmetic. Arithmetic. So if we look at number 7, the instructions are to state if the sequence is arithmetic, geometric, or neither. So the hint that I was going to give you for number 3 was get a common denominator. That might help, but you might be able to figure it out without doing that. So I'm going to write that hint down. Sometimes you can't get a common denominator. Sometimes you can. So in this case, it said, or I gave you a hint for a common denominator, but that doesn't actually help in this one because the denominators would get too big. It might help, but I think that the denominators would just get bigger and bigger and bigger. But I know that there's 8s reappearing. So what if I rewrote it, instead of getting a common denominator, what if I rewrote it so that the numerator is always 8? How can I represent things differently? So I'm going to say this one's 8 over 5. That already has an 8. This one, how can I make the 4 into an 8? Times by 2. So I do that in the bottom. I'm unreducing. That would be 8 over 6, right? All right, and then 8 over 7. That's this part. 8 over... 8 over what? 8. Now look at the bottom. So then what's this one going to be? 8 over 4. And then the next one's going to be 8 over 9. So in the denominator, we're adding 1. In the numerator, we're not adding anything, right? So I kind of think, how do I get from here to here? Well, there really isn't. I'm not adding one number. I'm adding it to the denominator, which is different than adding a single number every time. Does anybody have a guess for whether this is arithmetic, geometric, or neither? It's neither. The answer here is neither, because we're only doing it to the denominator. If we want it to be arithmetic, we have to be adding to the whole entire thing. So this one is neither. Neither arithmetic nor geometric. We don't make it geometric. It's a type of thing. How to tell if it's geometric? If you were multiplying by a single number every single time, then that would be geometric. Like we saw in one of the examples, we were multiplying by 4 every time. That means it's geometric.